But the biggest issue in the blockchain ecosystem right now is the very high barrier to entry for engineers. In terms of like, if I'm an engineer and I want to be able to create a smart contract, usually I have one of two options. I learn a new language that was designed for smart contracting, or I use an existing language that has been predetermined by the people who've created the blockchain. The fact of the matter is that it can take days or even weeks to learn a new language, and most engineers don't want to have to invest weeks of their time in order to be able to create technology for a platform that might not exist in a few years because the ecosystem is so rapidly evolving, right? Like Ethereum, for example, is a great platform, but we don't know that Ethereum is going to be the thing that's going to be here in 5 to 10 years. So any applications that are built on Ethereum might not exist, and any engineers who have spent time learning Solidity might not, be able to use that skill. So what we're doing to mitigate that is we're allowing application engineers to use any language that they're already using, any kind of tool sets that they're already using to create their applications, and just build that onto the blockchain. So if you're a Ruby engineer, or if you're a C++ engineer, or Python, or Java, or any other language that already compiles to WebAssembly, you can write it in that language and have it run on the chain. Another issue that we're solving is scalability. This is something that's been talked about really widely in the blockchain ecosystem, and it's a huge topic for discussion. But the way we're tackling this is actually by using the same infrastructure or the same language that is used to develop the telecom industry, Erlang. So anytime, right now, you make a phone call, you send a text message that goes through an Erlang server somewhere in the world that processes that and routes it to the right place. A huge issue with telecom is you can't have these servers go down. It's not acceptable if someone's in the middle of a phone call for that call to be dropped if there's a software update that needs to happen, or if a server goes down somewhere. That shouldn't have a huge outage in the worldwide network, right? So Erlang was built by a company called Ericsson in 1986 for the specific purpose of scalability, interoperability, and to be able to support uninterruptible systems. And the Open Telecom platform is an uninterruptible system. You can't just cut it off whenever there's a new update happening. And these updates happen often. It's software. There's bugs that get discovered that need to get fixed quickly. If there's a vulnerability that's discovered, that has to happen in a timely manner. So you can't have systems going down. Erlang has hot code reloading. So instead of having to take down a system, update it, and then bring it back up, you can actually update it while it's running. So we're bringing that into Elixium, allowing people to, instead of having to bring down a node, for example, or a miner, and having downtime per node, per miner, whenever there's a new software update, nodes can opt into auto update. So instead of whenever there is a new software update, you have a potential to have a hard fork or a soft fork where parts of the chain don't agree with each other because some people have updated to the newer version of the software and some people haven't. With Erlang, you don't really have that issue. Everybody just automatically updates. In terms of scalability, there's a lot of fault tolerance built into the Erlang ecosystem as well. So we can think of the blockchain as a self-healing system, right? If there's a node that goes down somewhere, there's 1,000 other nodes that can cover for it. But what if nodes didn't have to go down at all? Erlang has self-healing ability within the language itself. So whenever a part of a process fails, it is restarted automatically by the language. So now you don't only have healing or self-healing and polymorphic ability on the macro scale, you have it on the micro scale on a per node level. So if a process fails on a node, the entire node doesn't get restarted, just that part. But yeah, so scalability, privacy is another thing, and yeah, that's Elixium.
Thank you, Alex.